Okay, thank you. Okay, can you see my screen? Do you all see my screen?
We can see your screen, Richard. There's a question on the chat
Okay.
from Tejas. And Tejas, if you're using Mac, you should already have in Git installed, Tejas. So if you do a Git on your command line, like how Richa will show you, it will basically give you a
Yeah.
couple of things, So you don't need to install it, Tejas, if you're on Mac.
You can just try running Git and see if you get this output. Did it work for you? Okay, perfect. All right. So we'll start with your setting up the org on your account. So I'm assuming that all of you went ahead through the steps for creating a GitHub account, and you have your account created and you're logged into your account like this. What you can do is on your right hand side, you will see a plus sign. You can go there and create a new organization. So that is how you organize the entire repository, and you create different uh, folders, kind of folder kind of structures where you can hold different sets of files, or your programs, whatever you're writing. Say if you're writing one for your personal use, you can create one org there, and then if you're writing it for the team's use, you can create another organization. So you can just go ahead and create like my org or test org or something that you um, want to create. Like you can give whatever name you want to give. So since I already have my org created, I am not able to create that again. So that is there. Then the next step you can do is, currently you do not have any repositories created. I was trying with this one, so I have this one created. So the next step that you can do is you can click on new here, and under your organization you can create a repository. So let's create my first repo. And then, as I had mentioned in the last section, if you want, you can give a description, and then private are paid repositories. So usually, like unless like it's pressing that you have to have a private repository, try to go for public. I don't know if you see the internal option or not. That is something enabled for my company, but you can go with public and then click on create repository. That will end up creating a folder under your my org organization that you created. So basically you're kind of preparing to um, create a storage, like how on your computer you have C drive, and then you create different folder structure. One is for storing your photos, one is for storing your songs, one is for storing maybe your programs that you're writing. So similarly, like you're creating repositories here, and mainly this is used for collaboration with multiple team members. So as you see here, you can add teams and collaborators here. So if you had created this one, we'll try that step next, but first we'll go through these steps to link this repository or the folder that is created on cloud with a folder on your local machine. So we'll go ahead and create a folder on your machine now, which says the same name as you gave your repository, as you named your repository. So I created that folder. Now I'm going to go inside that folder, and then these are the different commands that you use. So basically I have a cheat sheet for you that will give you all the instructions, what it is and what this is used for. I will share this with all of you on our channel, and then you can read through this. And basically, if you have any questions, you can reach out to us on Slack to try it out. But basically, this is the command that I'm going to run now. So as it says, like, create a new local repository. And then basically what we are doing is you are initializing, or you're setting that this folder that I have created on my machine, I want to link it to the folder that I have it on GitHub repository in cloud. So that linking action is going to happen here. So as it says, initialized repository. So as a result of that, what happens, it creates a .git folder under your local folder on your machine, and basically it has the information that it needs to keep connected with your repository in the cloud. Now the next step what we're doing is git add. So basically, git add command, we are just creating a file named readme.md. So usually, like in the repositories, what we do, the readme.md files are used for giving specific instructions that you want to give for the project or the folder that you just created in your repository. So we'll go ahead and say create me a readme file. So it created, did not match any files. What happened? Oh,
Did
sorry.
you?
I missed the first step. I missed the first step. I'm sorry. I didn't echo and create the file. So basically, what you're doing as a part of echo command, you're saying that this text that is shown here, create a readme.md file and add this text to that file. So it's the command for creating that. Once that is created, you're saying that now this new file that is created, link that or add that to the git folder. So basically you're saying that I want to mark this file to be saved to my remote repository or in the folder that is in the github. So this will now link that folder. Next is the commit command. So basically the commit command, what it does is the um, init, which created a local folder on your machine and linked it to your git repository. Commit is you are just storing or saving the file that you just created on your local folder and marking it as a file that has to be sent to the git. So if you go ahead, and then usually with git commit command, what we do is we add some kind of description that tells is, hey, what is the action that I'm taking on this file. And you will find it more and more useful when you're writing programs and you are changing logic in your file. So somebody say, I change some logic and I save those changes in my repository, and say Ram is downloading that repository on his local. And if he takes a look at the history, we'll go through that a little later in the class, but if you go through that history, it tells you like what all changes have been done all this file. Say I So with this one, it is telling that this is the first time I'm adding this file, so this is my first commit. So now the file is saved on your local. This is now telling that link this to this specific folder on the GitHub platform. So basically, it created a local folder on your machine. Now you're saying that this is my remote directory. Go ahead and link it to this remote directory that is created. So this is the address, and then this address we use even from if when we want to download the code from the GitHub repositories on our local. We'll try that out a little later once we have everything stored. So we go ahead and added the remote repository on your local. And now you're saying that whatever changes I have stored as a part of my local folder, send that to this. So right now you see that there are no files or anything added here. But once we push this, and if you come back here and refresh this, you will see that a file has been added, and this is the text that we had added to this file. Now, I already have this folder created on my machine, so all I can, what I can do is I can go ahead and say open. Let me just take the, right. So this is my repository. I go ahead and open it in IntelliJ. Once I open it, I see that the file that is here is this file is created here. So now if I want to add another file, I can do it from here too. Like you can just go ahead and say new file, and you can say that text.txt. And as soon as I add it, since now we have this project linked to the remote repository that we created on Git, it knows and it asks you, it prompts you to check with you, is this file is something that you would like to be saved to Git? And it marks it as yes, it can be added to Git. If you say cancel, you don't want to add it, it won't prompt you to add it, or it won't show you that there are changes on this file if you keep making changes on this on your local machine. So I'll go ahead and add it right now, and then I'll say that first line in test. With earlier method, what we saw is we saw the commands, how we can run add the file and commit from your command line prompt. Through your IntelliJ also there is a way how you can add the file. So what you can do is, once you have Git installed, under your VCs menu in your IntelliJ, you will see a whole new menu for Git. And this is all the commands which are needed that can be executed from your command line. And also you can look at the version control tab on the different panes that you have available in IntelliJ. Under there it will show that what are the changes, or what are the files which are changed on your local machine. And this is how it shows you, like this is right now being marked as green because we just added that file and we told Git to mark it for adding that to our remote folder. So basically I can right click on that file and I can say commit file. This is exactly git commit command what we executed from command prompt, and I can say that first commit on test on this file, or whatever, like command that you want, commit command or message that you want to add. And then if you just say commit, it will save it only on your local machine. But if you say commit and push, so it's basically two-step actions that we executed on command prompt, where we had first said git commit and then we said git push, and that ended up resulting sending this file and the entire data to the remote folder on your GitHub repository. So the similarly, what you can do is you can carry out the same actions through this GUI provided or the plugin that is available as a part of IntelliJ. So I'll go ahead and say commit and push. And now it is checking for me, sure, do you want to push these changes? And I'll say that yes, push this change. Now if I go ahead and refresh it here, you will see test.txt file has been added here. Now I'll go ahead and I'll add second line in test. Again, go ahead, commit the file, second commit. I'll say commit and push. And one more thing before all right, that's fine. I clicked on. So I push those files. Now I come back here. If you see the latest version here, now we'll have two lines added here. Earlier there would have been only one line. So as and when you are making changes, all those changes are tracked here. You can see all the commits here. And here what you can see is the first time when I pushed it, it had only one line. So this file didn't exist before. I committed it for the first time. And when I pushed it, it had one line added. And when I pushed it again, it had one line added. So basically what you can do is you can carry out the same actions through this machine, and this is the version in the remote folder or the repository in cloud. What are the changes that you have made from the version that was already there? So it's telling that this line is no longer there in your latest version, and this is the new line that you just added. So this is another way of comparing your files with the version that is already saved to the remote repository. I'll go ahead and commit and push this now. And you will see a little bit different markup now in the file with this third commit. So what it is showing here now, the line that is marked in red has been deleted. So the red color shows the change that no longer exists or something that has been deleted, and the green color shows that something new that got added as a part of this commit to a particular file. Any questions so far? Is it clear, confusing? Do you want me to go over something again? Yes, no, maybe? Can you all still hear me?
Yes, I can hear you.
Okay. So any questions? All right, I guess not. So now with this one, we just saw, like, you created one single folder and how you basically um, sent different files from your local machine to that folder. Now, before we move ahead with the concept of how multiple people can work on multiple versions of the same repository, just wanted to show you how I can share this code that I had created with um, the team members or somebody whom I want to work with. So basically, what I'll go ahead and do in that case is I can go to settings and I go to collaborators and teams. Here I can go ahead and look for um, Ram. I'll add him here as a collaborator, and I have given him right access to this repository. So he can get the changes from this repository, he can write changes to this repository, and that way we both can collaborate on the same set of files, same set of code, and then we can work together on building the program that we want to build. And then how Ram will go about getting this code on his local machine. So he will come to the repository. I'll share this URL that is in browser with him. So that will take him to this page. He'll come here and click on the clone. So clone is basically you are creating a copy of that on your machine. So I'll go ahead and for now what I'll do is I'll try to clone it at a different location. So I created a folder and then I'm going there. And the command that I use for cloning is git clone, and the address that we copied from clone or download button here shown on the GitHub page. So I'll go ahead and do that. And now it created that folder under this clone example for me. So this is how you will be able to get the code on your local. Now, once I got that code, what I can do is there are multiple ways you can create a branch from here. So basically, you can come here. Where did the button go? Hmm, no. There used to be a way here to create a branch from here, Ram, right?
I don't remember it. I've never used the
Okay. All
UI
right. Oh
to.
no, 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 no. Yeah, yeah. It's here actually. If you go to the code and you see branch master, you come here, you can create a branch here. So basically the concept of branch is what, so master branch that you see here, that by default gets created when you are creating the repository, it is considered to be the latest and greatest version of your working code. So you would want to save the code in master, which is working perfectly fine, which doesn't have any errors. And anything that you are making changes in the files that you have already here, it is usually recommended that you create a separate branch. So basically, you create a copy of this into a separate folder altogether. You make the changes into that separate folder, and then what you do is you copy the file from that new folder that you created to the master folder back again once it's all ready and working fine. So we'll go ahead and create a first branch here. And now you will see that this branch has been created. It has been created from this master code, and it says this branch is even with master. And what that means is the code or the state of the files which you have added under master folder are same as the state of the files which are under our branch. As and when we make changes and send those to this branch, you will see that it will start showing you that there are changes in the files from the version that is in the master branch. So we'll go ahead and either you can clone the branch directly, but since I already have the project set up here, what I can do is I can use either the GUI. So basically what you do that for that is first you go to Git and you say rebase, and you select the option from the git root, whatever your master branch, everything is you are trying it to rebase. And then what happened, basically update project. You'll go to Git, and then why it is not showing me here. Okay, so basically the command that I'm using, I'll try to look for that menu option where it is, but I'm using command key, um, command here right now, and then it shows me the option to update project. I'll get you where it is available in the GUI. But and then this will sync state of your branch that is on your local with the version that is in master. And then you see here that it is showing currently I am on the master branch. If you look here, and then if you look at it, it shows you what all remote branches which are there. So basically what it is telling you that this branch is right now only available on your remote folder, that is the repository that is hosted on GitHub Cloud, but not on your local machine. So now I'll go ahead, click on that branch, and I'll say checkout. So checkout is the command that lets you switch your folder on your local machine to the new folder that you have created in GitHub Cloud repository. You can also use the similar command from your command prompt, and you can say git check out, and you give the branch name. So basically I would have used the command that said git check out first branch. And then oh, I switched the folder. Let me switch the folder back. So this will, since I already switched that branch, it says already on first branch, but this is the command that you will use from your command line to switch the branch. Now, what we'll do is we'll go ahead and make the changes to this file. We'll remove the third line, and I don't want third line. This is the fourth line, I'll say, and I will push the changes. I'll push it. And when I go back to my repository here, it says that I created this branch. This branch is one commit ahead of master. So what it is telling me that there are changes that you made on this folder which are not in sync with the main branch that you had created as a part of your repository. Now, how can we get these changes synced to the main branch that we have? And for that, as soon as you push some changes, it shows what you should be doing to get it added back to the main folder you created. So you click on compare and create a pull request. So basically what you are doing here is you are creating a patch. Basically you are creating a list of things that have changed that need to go back to the main folder that we had created in the repository. So, and this action of creating a pull request is creating a patch and then sending it back to the main folder is called as merging. So basically you are merging the changes from one folder to other folder. And then you can give some, you know, uh, title here, first branch merge, and you can create a pull request. So as a result of creating this pull request, it shows you which files have changed. Now we go ahead and look at that. It's like, okay, I changed the file text.txt, and what happened here is I deleted the line which says third line and I added the fourth line. Now, as a part of that, usually what we do is we basically have somebody to review the changes to make sure that unknowingly we didn't make a change that wasn't supposed to be done. And if it is something that you saw that this should not have been done, what you can go ahead and you can check on, do we still need this? And the person who had created this change, you can add that person, or the person who created this pull request can come here and see those changes listed here. If you need it, I can go back to my code here, and then I'll say that, oh, I really needed that line, I shouldn't have deleted it, and I can go ahead and say that this is the version that I want to check in, and then I'll go ahead, commit the file again, and the changes will be reflected here. So your line is back here, and it shows now only the fourth line is created here. Now, one thing that you need to keep in mind is you may or may not be going through the reviews, like should it be there, should it be not there. But to get these changes back onto the master branch, you will see this button if there are no conflict. So basically the concept of conflict is that is, suppose me and Ram both were working on this file, and Ram had created a branch like this before, and he worked on that, and he had a newer version of the same file in master which conflicts with this line number. Say Ram changed the third line to say something else, and then I changed to say something else. So these two things are in conflict now, they are not matching. So in that case, what Git prompts you to say that, hey, there is some confusion between what should be the latest code in the master branch, which one should I keep? And then you can take a look at those changes, and how I showed you, like you can make the adjustment and changes on your local, you can work through that. And once all those changes are resolved, you can click on merge pull request. I said merge it. I usually go ahead and delete this new folder that we had created, and then you come back to your first repo, and if you take a look at the file, now it has the version that you created on that branch, and all the changes are added in here. Anything else? Any questions that you didn't follow through what I just showed you? You want me to go over something else again? Ram, would you like to add something to this? Did I miss anything?
I think you're good, Richa. So Tejas, if
Okay.
you want to send me the project, you can maybe put it in Git and send it to me, the project that you think there's a bug in your right turn. So
All right. So as I said, like try it out yourself. I'll share the these commands, so these are handy for you. I'll suggest if you want, you can try these commands, or as I showed you, you can go ahead through your plugin that is with your IntelliJ, which makes it a little bit more graphical, and you can actually see what you are doing if you are not a big fan of trying all these things from the command prompt. All right. So
So
on to
another
you, Ram.
use case of a branch is basically, let's say Tejas sends me his project. I will create a branch from that project and make the changes on the branch. And I will let Tejas know, hey, the changes are on the branch. So Tejas can look at the branch, make sure that the changes are okay. And if he is comfortable, then he will take those changes and push them back into master.
Okay.
Any questions for Richa on the Git? All right. So today we'll be talking about Vuforia. Hey, George. So today we'll be talking about Vuforia. It's going to be a theoretical lesson. Before we kind of go ahead and look at the Vuforia code, I may kind of have to give you some basic background, and then we'll kind of go and look into the Vuforia code. Otherwise, it'll be a little confusing. So the first thing, let me go and share my screen. Can you all see my screen?
Yes.
Yep. So, okay, you can see the maps, right? So the first concept we will talk about is rotation, translation, and approach. Okay. So let's assume you are in St. Louis, right? And then you want to go to Chicago. Okay. The thing you need to know, I mean, so let's assume you're facing at a straight angle. Okay. You're facing at a right angle from here. So basically your direction is basically pointing to Louisville. So if you want to go from St. Louis to Chicago, you need to know this angle that is between your straight line, right, and Chicago. So you need to know this theta angle, right? So that you can basically turn towards Chicago and then go towards Chicago, right? So that is one thing you need to know, and that is basically the orientation. Okay. Other two things are, there are two ways you can do this, right? You can uh, either go straight up and then make a right turn, or make a left turn here, or sorry, right turn here, and then go to Chicago, right? Uh, so one is the uh, so when you go from St. Louis all the way to the top, it's called translation. And when you make a right turn and go towards Chicago, it's called approach. Okay. So these are the terminology you'll see in the program. That's why I'm kind of describing these to you. So there are three things you got to keep in mind. One is the orientation, which is basically the angle, right? And the other one is the translation and the approach. Translation most probably means that, hey, you're going straight up, and the approach is basically you're going in a horizontal line towards Chicago. Okay. Any questions on those three? So you need to know the orientation, you need to know the translation, and you need to know the approach. Any questions on those? All right. The other one you need to know, is when you place the camera on your robot, and also for the target, you need to give it a position and also the orientation of your camera and also of your target. Okay, so it's called the that position and orientation, right? Especially the orientation is a little tricky, and you need to know how to give the orientation. So it is, the rule is called the right angle rule. Okay, so I'm going to basically, let's say, if my target, is placed like this, right? How do I know what angle is this target, right? So assume, you were standing at the end of a field, okay? And it's called the right angle rule. So you take your hand and then you turn it towards you, right? So that is the way the angles work, okay? So for your x-axis, right? So I hope you can see me, okay? So for your x-axis, it's always horizontal. So when you turn 90 degrees, right? It's going to turn in the direction of your uh, pointing towards your thumb. So you will turn 90 degrees like this, okay? So that's a positive 90-degree angle. So that is for the x-axis, okay? So for the y-axis, it's going to be pointing like this, and a positive turn is going to be like this, okay? It always points towards 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 your palm, and the direction for y-axis will be straight like this. The third one is z-axis. Z-axis is basically straight up, right? So you point your thumb straight up, and then the rotation is always going to be towards your palm, right? So that's the positive 90 degrees, okay? So you need to provide like the angle or the orientation for your target, okay? So let's assume your target is at the end of the field, okay? And it's a piece of paper and it's at the end of the field. You need to give it exactly what orientation your target is in, okay? So let me take, like, if you can see my book, right? So first, let's assume I'm going to turn my book over the x-axis, okay? And you see my thumb is pointing outwards. So I'm going to turn it like towards me. So towards my palm, right? So that is a 90-degree angle, right? So if I do this, the degrees are going to be 90, 0, and 0. Okay. Any questions on that? It's going to be a little hard if you do not follow. Okay. So let me know if there are any questions on how I got my target to be 90 degrees here, or 90, 0, and 0. So if I basically turn it around on my x-axis, right, a 90-degree turn. So this is basically 90, 0, 0. Okay. Let's assume I'm going to do a turn on my z-axis. Okay. So my z-axis is going to be like this, and my positive turn, right? I have to turn it towards my palm, right? So if I turn it like this, the direction is going to point like this. Okay. So if at all your target is pointing in this direction, then it is 90, 0, 90. Okay. So that is the target position, especially from an angle point of view. Do you have any questions on that? Alia or Anya, do you have any questions on the angles? Okay. Uh, so the reason you need to know this is because you need to, when you're using Vuforia, you need to give the angles or the orientation for both your target and your phone. Okay, so most probably your phone, right? Your phone is going to be uh, something like your most probably your phone is going to point like this, okay, from the robot, right? But how do you get to this position, right? So you basically start off with your x-axis, then, right, you basically turn uh, towards your palm, right? So that is a 90-degree, and then over the z-axis, right? You turn like this over the z-axis. So you'll turn like this. So that is basically 90, 0, 90. Okay. And also you need to give it your initial starting position, which is also an XYZ, but most probably you'll not use the z-axis there. You'll say from an XY perspective, what your starting position is. Okay. So there are two things to when you're using Vuforia that you'll pretty frequently use, and not only from Vuforia, right? Basically, when you're trying to go from position to position B, you'll be using these two things. Okay. So some pseudo code in order to in order for Vuforia to work, you'll have to initialize Vuforia. Okay. So this initialization code most probably you can get from the standard samples that they provide. I would not waste too much time on initialization part of it, at least, because you can just go and get it from your standard code that they provide. You will load your vision targets. Uh, this is also something that they will provide you a file of, and then you will just load those targets. You will get a target, okay? And then from that target, you will get an initial, you can set the name, and then you'll set the initial position of your target, okay? And this is where you have to give it how your target is placed, right? Uh, what is the position, and also what is the orientation. And the orientation, you'll basically give it in 3 angles. You'll give it as X, Y, and Z. Okay. So once you got your target, you will get your target listener. Because when you say a listener, right, things keep getting updated. That's why it's a listener, right? It consistently listens to the changes in the position. Okay, so you want to get a listener, and on the listener you will set your phone location. Okay, so once you have set your listener, right, this is basically kind of pointing towards your target location. Okay, so you'll do listener got get updated robot location. So that will give you the last known location. And this is most probably a matrix. You do not need to know the details of the matrix, but the two things that you need to know, right, are basically the coordinates of the target, right? Because you need to know what your final destination is, right, from an XY perspective. So the way to get that final destination, like for example, if you're going from St. Louis to Chicago, you need to know what your final destination is going to be, the XY coordinates, and also the angle, right? So you need to know that angle. The way to get the XY coordinates are basically using you get the matrix, and then from the matrix, you get the translation, and you say get data. So that will give you some coordinates. Okay, it'll give you the XY coordinates. And once you get the coordinates, the other way to get the orientation is basically you say orientation.get orientation. You pass the last known location that Vuforia returns to you, and you basically tell it, hey, what is your axis basically. I mean, this is always going to be extrinsic axis. Okay, don't worry about this. You'll give it the order of your angles, and unlike the last time what we saw for gyro, here in this case, right, you'll always use x, y, z, and the whether you want the output in radians or degrees. Okay, and then you'll tell it, hey, I want the third angle, right? Because third angle is most probably the z angle. Uh, that's why you say third angle. This will give you the robot angle. Okay. So once you know the robot angle, right, you can basically, like last time we saw, if you know the angle, right, you can basically do a control turn towards your towards the direction where you want to go. Okay. And if you know the x and y coordinates, the final x and y coordinates, right, you should be able to find out the length by using some math. Okay, and maybe I will post the math that you can use in the Slack channel. But you know, if you kind of know Pythagorean theorem, a little bit of the trigonometry, right, you can easily calculate based on the x and y location what is the actual length you need to go to, right? And then you can figure out, if you know the length, then you can use your encoders and then go to that specific position. Okay, any questions? All right, I will just do a quick summary. So if you're going to use Vuforia, Vuforia is most probably used when you know there is a vision target, right? So you want to go to that specific vision target. Okay, uh, so you have to initialize Vuforia first, and this code is most probably going to be provided. It's going to be provided by FTC. So I would just copy whatever FTC provides. It's a little complex, so I would just copy and paste whatever they provide. Then you would load the vision targets. So once after you load the targets, you get a specific target that you want to go towards. Just going back one step. When I say load vision targets, basically they will give you a file that has some data about the target. Okay, it can be I think a sky stone or whatever, right? So once you just point it to the data file and it will load that data for you. Yeah. So in your program, you will call get target. And for that target, you will just set a name. This is just for a display purpose. And you will set the initial location. And when you're setting the initial location, you can, I mean, there are two ways to approach this. You can either just say the location is going to be 000 from a position perspective because you really do not know. But some people basically will before the match starts, right? They will exactly know the X, Y, and Z coordinates of the target. Okay, so they can provide that too. And orientation also from an angle perspective. You need to say, is your target vertical or things like that, you know. Once you set your target, you get your target listener, you set the phone location on the listener. That is the initial setup, okay? And this code will not change except for this specific portion where you need to give the position and orientation, right? So you can just copy this, whatever FTC provides, except for this specific code, okay? Uh, so once your target is set, right, in your while op mode is active, you'll basically say listener.get updated robot location, which should give you the uh, last location of your robot, right? And since this is in a loop, this will continuously change, okay? So once you know the last location of your robot, you'll get the translation value, which is basically the X and Y value, okay? So you do get translation.get data, and that will give you the coordinates, and the coordinates of 0 will give you the X value, and the coordinates 1 will give you the Y value. This is basically your final destination on how much more you have to go. Okay, and this is basically just telling you how to get it, but then you will use this information using encoders to travel that distance. Okay. So like we discussed, if you were to go from St. Louis to Chicago, in addition to the XY of Chicago, you will also need to get the angle, right? The way you get the angle is use your orientation dot get orientation, and you pass it the location that you got from Vuforia, and you basically give it some other and parameters here, but these parameters are going to be constant, so you'll not change it. You'll say your axis extrinsic, the order is YZ, XYZ, and the output you want in degrees. And we want the third angle because we are primarily interested in the Z angle, okay? So that will give us the robot angle. Any questions on this? All right, let's go and look at some code. And I'm not going to type things out. This is going to be more a theoretical lesson. Unfortunately, the simulator does not have the vision Vuforia installed. Okay, so we cannot practice it, but we look at some code. I'll post the code, and if you have a robot, right, you can go ahead and give it a try. Okay. The first bit of code I'm going to go is over the setup Vuforia. Um, like I said, you'll most probably copy this setup Vuforia from some of the standard code that's given to you. And the standard code that's given to you, right, it will be in a folder called FTC Robot Controller, source, main, Java, robot controller, and external samples. Okay, so they will give you some samples, and this initialization code should be pretty similar to what you get from that. Okay. The one thing to note is you will have to create a Vuforia key. And there are instructions on how you will basically create this key if you go ahead and look at some of the samples that are provided. Okay. And you also have to tell it what camera you're going to use, the front or the back. But I would say go ahead and copy this code from some of the standard code that's given. Okay. After that, you would basically load your trackables or load your targets, right? And they will provide you a folder where this information is. Okay. In your assets, they will give you what, based on the competition, they will give you your target folder. Okay. So you'll go ahead and provide it like FTC underscore 26-17, right? So basically, you will go ahead and give it that information. So this should basically load your target. Okay. Don't worry about this one for now. You'll use this if you basically have multiple targets, but if it's one target, you don't need to load this. So after you load the targets, right, you'll get the first target, you'll set a name, and then you're basically going to tell it the location of your target. Okay. And if you kind of see, it's an Opengl matrix. Okay. And Opengl matrix, basically you're going to give it 6 values. Okay. The XYZ, that is basically the position of your target, and the angles, right? So 90, 0, 90. Okay. So if it is 90, 0, 90, right? How your target is actually going to look, right? So if I basically start off, right? So let's say I'm going to start off at this position. So the first thing is 90, right? So basically that means on my x-axis, I'm going to rotate 90 degrees, okay, towards the palm, right? So that tells me that is my first rotation. There is no Y rotation, right? So basically I don't need to, this is my Y axis, so I don't need to rotate there. And my Z axis is like this, right? Pointing up. So it's saying there's a 90-degree rotation, right? And it's towards the 90-degree rotation uh, like this, right? So basically if I turn it like this, that is a 90-degree rotation. So basically it is telling, I mean, at least this code is telling that, the target position is like this, okay? And 0, 500, 0, this is, I mean, this depends on how you are comfortable. Most probably when the competition starts, right? this is like saying that, hey, the target is basically on the x-axis is 0 degrees away, 0 millimeters away. On the y-axis, it is 500 millimeters away, and z-axis is most probably going to be 0. Okay, but this is basically saying that my target, initial starting position is basically from an x-axis perspective, there's no variation, but it's from a y-axis, right? It's 500 uh, millimeters away. Okay. So any questions on this number? Because this is one number that you will have to set uh, when you first set your target. Okay, you'll need to set your X, Y, Z from a position perspective and also from an angle perspective. And I've seen some programs where basically from when they're creating this matrix, right, they create a 0, 0, 0. Okay, and they basically rotate until they find an initial target. Okay, but some basically give it an initial position based on the field data that you already get. Similarly, you have to create the phone location also. It's also in the OpenGL matrix thing. So you give it the XYZ of where the phone is relative to the robot. Okay. Uh, so basically it's saying that, if your robot is like, let's assume your robot is like this, right? From an x-axis perspective, the robot is right in front, like it's just in front, like so there is no distance between the robot and the uh, uh, end of the robot. Okay, and y-axis basically tells me that, hey, I think there is some distance between the end of the robot from a y-axis perspective. It's 225 millimeters. Okay, and z-axis you normally ignore it here. And this 9000, right? What it means is basically the camera position, right? Your camera, basically, it's not going to be your phone, right? Or the phone camera is going to be most probably like, because it's a 9000, it basically means that it's like this, okay? So these are the two numbers that you have to set, okay? So you basically, on your target, you give it the, create a matrix and give it the OpenGL position. The first X, Y, and Z are the coordinates, and then U, V, and W, right? The last three numbers are the angles. Also for the phone, you have to give those three numbers, okay? Then you get the listener for the target, and then on the listener, you basically set the phone location. So this code also is going to be pretty static, okay? Of all this setup Vuforia, right? The two things that you need to worry about are this bit here. What is your position of your target from the coordinates perspective and from the angle perspective? And also what is the position of your phone relative to the robot from the coordinates position and the angle, okay? Any question on this bit of code? So there's a helper method for create matrix, okay? You don't need to worry about it. This is another thing that you can just copy and paste off. But basically you give it the X, Y, Z coordinates and the orientation angles U, V, and W, okay? So you just copy and paste this and you're good to go, okay? This code is a little confusing, right? So that's why I'm saying just copy and paste the Vuforia setup portion and worry about the setting up the locations and creating the matrix, okay? Right, any questions there? All right. So the main bit of code that you will have to write, right, is basically you'll do a setup Vuforia. That is the code that we basically just saw, that will set up your Vuforia targets. Then you'll create an initial matrix, right? Just for the last known location, just start off with zeros, everything zeros. You activate Vuforia, you activate the targets, the Vuforia targets. And then you created a listener, right? So you'll say listener.get updated robot location. So this will give you the latest location of your robot. And once you know the location, once you know the matrix, right? The way to get the translation is basically by using the location, right? You'll use the location, get the translation.get data. This will give you the coordinates. So this will give you the X and Y coordinates. And also if you know the last known location, you can get the angle by basically calling this get orientation.get orientation code, pass in the angle, and this the rest of the data is pretty static. You make say it's extrinsic. The order of the angles is Y, Z, and X. And since you want the Z axis, from a rotation perspective, right? So you'll say third angle over here, okay? So that will give you the angle. Okay? And if you are using the encoders, right, you can basically calculate what distance you need to go by using this X and Y direction, okay? So most probably what you'll do is, because you know the angle, right, you'll rotate to that angle. And if you did your exercise last time, right, you'll use the robot angle and do a control turn towards the target. And then from that, you'll use your encoders. You can, based on the X and Y, you can calculate by using some trigonometry. And I will post that how do you calculate the exact distance, right, from your current position to the position that you have to go, right? Or the other way to do that is by basically consistently looking at the X and Y and seeing what the distance is, right? And if the distance is not equal to 0, you consistently increment the power of the, you set some power to the robot, right? Um, Either way, I think you need to know the distance that you need to travel, right? Distance between your current X and Y and the target's X and Y. So that you can then, based on that, you can calculate the length. Any questions? All right. Yeah, at first it kind of seems a little complex, but just know that you have to just copy this setup portion. This create matrix is also a standard, right? You don't have to worry about that. And once you know the location, by basically you say listener.get location, right? That will give you the latest location, and you want the X and Y coordinates of your target, right? So you'll say location.get translation .get data. That will give you the coordinates, and the way to get the coordinates is by looking at the from the array that it gives you. The first element, the 0th element, gives you the X value, and the first element gives you the Y value. You also get the orientation by using the last known location. Just by a call to a function, you get the orientation, and based on that, you can use this information to do a control turn, and then also do the figure out the distance you should travel. Any questions? Yeah, unfortunately, we will not be able to try this out until your competition starts, right? Because once you get the robot, you'll be able to try this code out, okay? So I'll go ahead and post this code. Also, your competition starts, they will provide you some samples that you can look at, right, for Vuforia. And then you can use the samples to try out the program, okay? Any other questions? All right. I didn't have anything planned today apart from the Vuforia and the GitHub topic. I will send you this code, but unfortunately you'll not be able to run it. Like I said, once your competition starts, you can probably try it out, or if you have a robot, you can try it out, okay? This is not available in the simulator, okay? So you will not be able to use the simulator to try this code out, okay? Right, if there are no other questions, next week we'll be talking about the PID controller, and that will be our final thing that we talk about, okay? And the PID controller is mostly used so that, if you have to turn 90 degrees, right? So that you don't get the slippage, right? So that it just doesn't go more than 90 degrees, So that's where, as it approaches 90 degrees, you want to slow down, right? So that's why you're going to use the PID controller, And next week we'll go ahead and see how to use the PID controller, okay? All right, if there are no other questions, I think we will meet next week. All right, ladies and gentlemen, I will talk to you next week. And Tejas, you can send me your code. You can either put it in Git and send it to me, or if you want, you can paste it and I can take a look too.
Ram, do you want to start a repository and check all your code into that repository now so that they have
Yeah,
it at this?
yeah, I will do that.
Okay, cool.
All right. I will talk to you all next week then. We will talk about the PID controller.
Yep, and Ram, don't forget to post the recording. Everybody is asking for the recording of the session.
Okay.
All right. Thank you. Bye.